All right, ladies and gentlemen, so today we're moving into the third lesson, which is now we're going to have one base and two exponents. And we're also going to talk about, well, what happens if you're raising two things to an exponent and how does that work? So our rule over here, again, I'm going to show you an example because then we can look at the official notation here. But let's say I have an example of 2 to the third to the fourth power. Well, this 4 tells me I need 4 of whatever's inside the parentheses. So I need 2 to the third times 2 to the third times 2 to the third times 2 to the third. Well, our rules that we practiced yesterday tell me that if I'm multiplying the bases, I add the exponents. So 3, 6, 9, this is going to give me 2 to the 12th. Well, what these rules are telling us over here is that what I can really do, my shortcut, is that I can multiply the exponents. All right, so when we have this, we multiply the exponents. Right, and that again is what all this fancy notation is telling you. Basically did this using x as my example. So here they're saying x, we would have this m times, and then m times times m times times m times, and so on. Basically what I showed you there with the 2. Our other problem that we're going to be working on is, well, what happens if I have two numbers inside, so two different bases with an exponent? And the way this one works is that it's a lot like the distributive property. We're really going to take and we're going to share this with both things on the inside. And if there's a number there, then you're going to actually end up multiplying those together. All right, so let's see how this is going to look with some examples. So for number 1, here's my base, 15 to the third. I need it 9 times, so we're going to multiply those, 15 to the 27th. For number 2, our base is -2. I'm raising it to the 5th and then to the 8th. So that's -2 to the 40th. Remembering that anytime you have a fractional or an exponential, fractional or a negative base, then you have to put it in parentheses. So for number 3, this time I have a fractional base, but it's still going to be 3.4, and 17 times 4, I hope, is 68, because I didn't double check that. Even if I have a variable as a base, we're then going to do 7 to the 68th power again. So let's see what we have over here. Sarah wrote 3 to the 5th to the 7th equals 3 to the 12th. Correct her mistake. Write an exponential expression using a base of 3 and exponents of 5 and 7 and 12. That would make her answer correct. I don't know what that second part means, but her mistake was that she added the exponents instead of dividing, or sorry, instead of multiplying. So her correct answer should have been 3 to the 35th. Okay, this side is now going to practice a little bit of what we were talking about before. So this is telling me, right, I have 11 times 4, so it's telling me to take and multiply or distribute that base. Or, oh my gosh, I'm sorry, ladies and gentlemen. How about we distribute the exponent? So this is going to be 11 to the 9th times 4 to the 9th. That's what that's really telling me to do. Okay. For number 7, so now, right, I'm going to still share it, but I have something to multiply it by. So this is going to be 3 to the 10th, because 2 times 5 was 10, and 7 to the 20th, because 4 times 5 is 20. Right, same idea here. We're going to share it with everything that's on the inside, but I have actual numbers there to multiply them by. So 3 to the 10th and a to the 20th. Notice when I have a letter, we don't put any symbol in between when it's multiplying. So a number times a letter's multiplying is always going to be just shown like that. So this one we're going to share. We're going to have 5 to the 7th, x to the 7th. Here I'm sharing it with 3 things. 5 to the 7th, x to the 7th, y to the 14th. Because y had a 2, so I had to multiply those. All right, here comes another one. All right, 3 things. A to the 8th, b to the 4th, c to the 12th. So I'm doing it for every single thing on the inside. For number 12, here I just have one base, but I have 3 different exponents. I'm going to multiply all 3 of those together. So I'm going to have 4 to the, let's see, that's 6 times 2, that's 12, I hope. And for number 13, we're going to have 2 to the 18th, assuming I multiplied that correctly. 14, let x and y be numbers such that y can't be 0, because you can never have 0 in a denominator. And let n be a positive integer. How is related to xn and y to the n? So this would be x to the n divided by y to the n. So even as a fraction, you're still going, ooh, I wrote squared and not n. Sorry. So even as a fraction, it would get shared with both parts, the numerator and the denominator. That's what that's telling me. All right, let's see what's next. Oh, look at that. That's going to be our practice. Short video for today. So any questions, bring them to class. You do need to start memorizing these rules. So you have to memorize that when you are taking and you're dividing, you subtract. When you're multiplying, you add. When you have a power to a power, you're multiplying. But after that, it should hopefully be pretty easy. Any questions? Bring them to class and have a great night.